Hello, I'm Chris Gladwin, the CEO of Ocient, and welcome to another edition of our podcast that is all about data called Big Bytes with Ocient. This season, we've talked with leaders innovating with data in all kinds of industries like ad tech and government and financial analysis and others. And today, I'm really excited to talk about a topic that is near to dear and to me personally, the need for energy efficiency when architecting data analytic systems. And I'd like to welcome Amy Francetic, who is the founder of Buoyant Ventures, a venture capital fund focused on digital climate solutions. Previously, she founded and led Energize Ventures, and prior to Energize, she served as co-founder and CEO of Evergreen Climate Innovations. She has decades of experience spanning startups, private equity, research, and operations, and having worked with Amy, I can tell you she is a player in this industry. She knows the people, she knows the technology, she knows the issues, and it is fantastic to have her here. She and her firm Buoyant are also an investor in Ocient. That's how we got to know each other, and I am sure we're going to have a great conversation. So, Amy, good morning. Welcome.
Good morning. Thank you so much for having me. And I am a giant fan of Ocient, and you're very kind in your introduction. It's very humbling, and I will try to live up to what you have introduced me as.
Well, let's get right to it. I just want there's a big issue going on in the world, and we're going to need to talk about this, and that is the growing demand for data centers for energy. I mean, it has gone from people weren't talking about this to this is a big part of what's going on in computing and data, and it's something we need to discuss. So first, tell us what is really going on. With data center energy growth and the demand and the supply. What's going on?
Well, the demand for energy from data centers is projected to exceed the energy supply. And so that is becoming a limiting factor to the tech companies' ability to build data centers and to drive their computing and storage resources. So by the year 2030, the total energy demand of the hyperscalers is projected to be more than the country of Brazil. And so one of the issues is, how are they going to supply energy for these data centers, as well as how do you make the data centers themselves more efficient? We don't have unlimited energy. And so the concern is that we will need every kind of resource, fossil fuels, renewables, nuclear, to satisfy this growing demand. And so the unfortunate reality is that it will cause a lot of more fossil fuels to power those data centers because you're going to just need everything under the sun. And so a lot of the big tech companies have goals to reduce their carbon emissions, and this is kind of an impairment for them to be able to meet sort of those goals. And so we get concerned about how could you make the data itself more efficient? That was certainly part of the thesis that we had when we invested in Ocient. So I know we're going to talk about that, but in addition to making the real estate, the data center infrastructure more energy efficient, so you could do more with less energy, is there a way you could fundamentally change the way the software and the compute and the storage works?
Yeah, so that gets to my next question. I mean, on the one hand, we're reporting that data analytics, computing in general, data centers really have become the place where all enterprise computing occurs. So when we talk about data center power, we're really talking about computing. But other than endpoint devices like your laptop and your phone, like everything else happens at data centers these days. So that's really power for computing is shorthand for data center energy. So on the one hand, what you're reporting is that you've got this growing demand, like 20% a year of demand. Whereas if you go to the energy industry, they don't know how, it's just not possible. You can't just we'll have 20% more energy, next year and 100% more in a few years. You just don't build capacity like that. So this is a challenge that the industry is facing. I guess the first question is what's going to be the solution? I mean, is energy efficiency, compute per watt, storage per watt, amount of bandwidth per watt, is that going to become something we're going to talk a lot about and focus a lot on as an industry?
Well, I think we've never seen this kind of energy load growth in my lifetime. So, the all of the utilities are scrambling to figure out how to satisfy the requests from their customers, and most of the utilities in the U.S., their top customers are folks that are our data centers. So this is a very widespread problem. And I think,
Mm-hmm.
it's certainly going to cause some of this computing to go overseas and look for energy elsewhere. Okay, so that's number one, is like, if we have limitations from land, permitting, other things in the US that are going to make it harder to satisfy that, then folks are going to look overseas for different ways to do this. And then the the efficiency, I think when we looked at this as a firm and started trying to understand what some of the solutions were, the physical energy efficiency of the data centers themselves, they're already very efficient. So the older
Right.
ones less so, but the new ones that are being built are highly efficient. So
Right.
it doesn't feel like the physical efficiency, like how you're powering, cooling the
Right.
data centers, has a lot of headroom left to do this. So I think we have to look at fundamentally how we're doing the computing so that it requires fewer servers. I mean, that's kind of what I think is a unique opportunity, and folks haven't spent that much time on it. Certainly, people are looking at how do you make the chips more efficient. Okay, so
Right.
that is, a lot of the chip makers are working on new processors that are more energy efficient. So
Mm-hmm.
there's hope there that will help, the chips that go into the servers will be more efficient. But we have this paradox that of the more efficient you make something, the more you use it.
Yes.
So I think that it's the same thing that drove like energy efficiency of home appliances. When all the refrigerators became more efficient, the washing machines, it didn't necessarily change people's behaviors around how they used it. They just used it more, knowing that, okay, now this is more efficient. So I think that that's the challenge: is if we make the chips more efficient, if we make the data centers themselves more efficient, the hunger for compute is so intense that they'll just use all that up. So I think that I think, a lot of enterprise customers are going to actually look for ways to leverage all of their assets, their on-prem servers, their cloud servers, their unused capacity in, laptops and desktop computers. So they're going to get a little more creative about how they utilize all these resources. And the other thing I'll mention is that the pricing, a lot of the enterprise customers feel so beholden to the cloud companies. They feel like the pricing is out of control, and that,
Mm-hmm.
as those the cloud services companies look for ways to deliver this service, and if they have to pay more for energy, they're certainly going to pass those costs along to the customers. So I think we should assume that the projected costs of any of the cloud services are going to escalate, pretty dramatically over the coming years, as this fight for energy maybe makes people look for more expensive forms of energy, to sort of satisfy the low demand.
And it's like real estate, that if there's more supply than demand, or more demand than supply, price has to go up.
It
And
has to go up. Yep.
it looks like that's where we're headed. Is data analytics software something that can help solve the problem? What's the state of the art in, I don't know, utilities thinking about, you know, when they do certain operations of like maintenance, based on wind forecasts for the next day, or
Yeah.
software vendors like Ocient doing things like, scheduling maintenance operations that are very power intensive, like rebuilding if, a hard drive failed. Like, what's the state of the art in the industry? Are companies already doing everything they can with data analytics to make energy use and computing more efficient, or are we just beginning a journey here?
I think we're just beginning, because I would say that the utilities are starting to be drowning in data. Okay.
Mm-hmm.
And because they're in this industrial sector, the industrial sector has been slower to to join this sort of digital revolution. And the power plants, certainly a big machine like a wind turbine has 1,000 sensors on it. Okay. And those sensors are spitting out all this data. So people that own and operate the wind farms have to have pretty sophisticated teams to make sense of all the data that is being turned out from these wind farms. And on top of that, think about how complicated the grid is. The grid is a giant machine, that is determining sort of demand and supply, and then also pricing. And so you've got sort of pricing of energy at different times of day, and folks that are sort of buying and selling into sort of these financial markets. This is a very good software analytics problem, right? So we're in the beginning stages of the utilities' desire to have tools to sort this out. And it probably, even as of a few years ago, there weren't people that were data scientists at the utilities. This is a relatively recent skill set that's being added to the utility workforce. And it's also a real challenge because the people that know how to manage the grid, that are very experienced at it, are retiring. Okay, so when we've looked at this from an investment standpoint, any way to pass on the skills from this highly specialized aging workforce to these younger data scientists, right? This is a blend of sort of data science and physics, because it's a physical, these are machines. You're kind of like taking physics data, weather data. I mean, this is a massive data problem. And I think the utilities are just beginning to have folks, they're just beginning to hire people with those skill sets. And the goal is like, how do you get this next generation of managers of these assets up to speed with this aging skill set, as well as the sophistication that's now available from giant, reams of data.
Yeah, we're also seeing that same that we have that same observation at Ocient, that really we're just beginning this journey as an industry. We've been able to demonstrate consistently that when our software is implemented for very large, always on complex data analytic systems, that we can reduce power energy consumption typically by about 90% in the system. And what we're experiencing kind of internally in our engineering is that this is the first 90%. We're just beginning this journey, both as a company, as an industry. So, in the first 90%, you do the low hanging fruit, like, oh, this is not going to take us that long. It'll cut power by 50%. Oh, this isn't too bad of a project. It'll cut power by 30%. So that's kind of what we experienced in that first 90%. We're now working on the next 90% of power reduction, increased energy efficiency. It's harder. We did all the easier stuff, and now this is there's a lot more work with a lot less, result. But okay, that adds up to the next 90%, and we're starting to think about the third 90%. That gets really hard. So that's been our observation as well. Also with customers, when we've talked to utilities and folks like that, are both producing energy that could be more efficient and consumers of energy for data centers, they're also working on the first 90%. But the other constituency in this journey is the end customers, telcos, people that operate these big, giant, complex systems that do consume a lot of energy. We recently at Ocient did a survey we call Beyond Big Data, where we talked to hundreds of IT leaders at these kind of companies about what they're doing. And 71% of them said that they are tracking departmental carbon neutral goals as part of what they're doing. Do you think that's making a difference?
I think so. I think it is because, so our largest investor is Microsoft, right? Mm-hmm. They have one of the more ambitious net zero plans. They're trying to be completely carbon neutral by 2030, I believe is their goal. And they have enormous energy footprint, right, for all of their data centers, as well as they count their scope 3 emissions, which is all of the energy consumed by the end devices that their consumers or their customers use. So all of the Xboxes, for instance, right? So they're tracking like the core emissions of the firm to power their offices, their data centers, and then they're also looking down to the devices that are being bought by their customers. So they have very ambitious goals. And I think what it does is it makes the enterprises very aware of their energy supply. And so Microsoft is one of the very large purchasers of renewable energy in the world, and they're also very large purchasers of new forms of carbon capture, like some of these more experimental technologies that are trying to reduce emissions. They've been a very early customer of some of these newer technologies that could help reduce emissions, that they could purchase sort of offsets for their emissions from these carbon capture companies. So I think that
Right.
that's very positive because it's kind of moving things forward. It sort of sets a real goal of leadership for other tech companies. And the other thing is they're a global player. So they're trying to conform to standards that are um, probably more stringent than what we have in the US because they have a global footprint. So
Right.
like Europe has very ambitious goals for decarbonization and net zero plans, and more serious penalties for folks that are polluters. So they sort of set a standard that's a little higher than the US. And so, somebody like a Microsoft who's a global player is like not going to try to have all these different standards that they conform to. They're going to kind of pick a standard that's a high quality standard and then kind of, implement that globally. So I think that that is very positive. I think that there's a back to this, like, I don't think they can purchase enough clean energy to power their needs. And so that's why they're looking at offsets. And
Especially as their
just as
needs grow 20% a year. Like there's no way there's going to be 20% more clean energy every year.
there isn't. And so just as you said in your point about, the first 90% is easy. The second, 90% is really hard. That's absolutely the case in building infrastructure.
Right.
We
Absolutely.
to build energy infrastructure in places where it isn't today is going to require permitting that is more complicated. It's going to require transmission lines to transmit that power from the location where it's produced to where the load centers are, and that's going to cross over boundaries that are going to be harder and harder to permit. It's going to require that we look to there's a lot of rooftops that could have solar on them. We don't, there's if we try to penetrate rooftop solar, even 30 or 40% of all rooftops, we'd have enormous amounts of solar energy. But imagine now, like, think of the effort involved in putting rooftop solar on every kind of, like, available, suitable rooftop with good, sun assets hitting it in these locations, so that you don't have to transmit this. Like, that's complicated, and it's just going to take a lot of time. So we won't be able to. The building of the energy infrastructure won't keep up
Right.
with the demand that exists. So that will be the limiting factor for demand of from the data companies.
Yeah. The other thing that we think, and I know you've been a part of these conversations as well, that is going to be essential in addition to all that, how do we make more energy, particularly clean energy, is the industry is going to have to get a lot more efficient. And the way that's going to drive this industry to get more efficient is if customers require it. Right now, you look at an RFP from which is a purchasing, basically, here's my purchasing requirements. And it has a lot of information about capabilities and cost and serviceability and all this stuff. They don't say, and here's my requirements for energy use, energy efficiency. I can tell you as an absolute fact that if customers who buy these systems say, this is what I need in terms of energy efficiency, the industry will respond right away. So that's one of the things that we're working on. I know we're working on with you.
Yeah.
Since we just have a little bit of time left, I guess I would ask, do you have one kind of prediction you'd like to share about what's going to happen, let's say, in the next couple of years, as it relates to energy use and energy efficiency and growing demand for data center energy?
Well, I think what's intriguing, and some of the academics are looking at ways to, it's not like you need energy for all of these data functions at the same level throughout the entire day. So managing when some of the computing is being done to utilize when certain types of renewable energy are more available, I think
Right.
the sort of time of use is there's going to be some real opportunities around that, right? So if you're doing like batch processing, like you hinted at this, Chris, a little bit in your earlier comments, but if there's certain maybe kind of not in real time, it's not like you need to run queries on this data during business hours. Certainly that's needed, and you need you need power to supply that, and you need very good bandwidth for that. But there's probably a whole set of functions that could be done overnight. And when maybe you have not solar power, but you have wind power, or they could be done off cycle, or they might even be able to be done on-prem versus in the cloud. You know what I
Right.
mean? So like there's how you're managing when those functions are performed and on and in what locations. I think there's going to be that's a real opportunity. And
Yeah.
we're hearing academics talk about that. Um, we're looking at some startups that are considering that as sort of one of their value propositions. And I think that it's going to open up an opportunity for some innovation there.
Yeah. It's not just the total amount of energy used, it's when you use the energy and also what is your peak usage at a given point in time, especially, what's your peak usage when it's 106 degrees like it was last week in Southern California? Like, that's really important to minimize. Really important.
Yep,
So,
yep,
look, it was
100%.
it was great to talk with you. I knew we'd have a great conversation, fantastic insights. Thanks so much for joining us today, Amy. I'm sure we'll be talking more about this, both with you and on the podcast and in the industry. This is a industry changing trend that we're talking about here. So thanks so much for participating, sharing your insights. Thanks everybody for listening. And you can always find out more about Ocient at ocient.com. So thanks again, and we'll see y'all later.
Thank you.